Hello and welcome to my channel. I am BeardedDev, bringing you another SQL tutorial, and we're going to be looking at clustered indexes in this video, but we're only going to be looking at them from an OLTP perspective because there's a different approach in terms of data warehousing or OLAP. So in summary now, we're going to look at indexes at a general level. So I'm not talking specifically about clustered indexes here, but all different types of indexes. So they allow for faster retrieval of data. But people can get carried away with creating indexes, so there is a trade-off in terms of indexes. So if loads of indexes are created, so that speeds up our read operations, we're able to retrieve data very quickly, but our DML operations might suffer. So if we're inserting data or updating data, we can actually slow that down because those indexes need to be maintained. So what you'll pick up from this video is don't go off and just create loads of indexes that would allow covering of all different queries. It's important to have a balance. So in this video we're going to be focusing on clustered indexes. Now clustered index do require an alter table permission to create or rebuild. When a table does not have a clustered index, then the table is stored as a heap, and if the table has a clustered index, it is stored as a B-tree. And the data is stored in order of a clustered index. So whenever I think about a clustered index, I always like to think of a filing cabinet scenario. So we've got one drawer that holds loads of files. Now if we just put that in order as we create files and just insert them into the drawer, there's no specified order. When we're looking for a particular file, we just have to search every file until we actually get to it. But if we actually organise that to say store that in alphabetical order, then we'd have the benefit of we know straight away where we need to go. So if we have the 26 letters of the alphabet with a file standing out, we know if we're looking for maybe we're looking for employee data and we're looking for somebody with the surname of Barnes, we know we can go straight to the B section. So we've saved ourselves quite a significant amount of time. We don't have to search for everything, we just need to go through a smaller section. We can only have one clustered index on one table, and clustered indexes are effective on columns that consist of unique increasing integers such as a primary key. And in fact, when you create a primary key on a table, a unique clustered index is automatically created. So you might not have known that, but as soon as you add a primary key, an index is created. And that can be beneficial on queries that involve joins. So particularly in an OLTP scenario, when we're looking to retrieve data, typically we have to join a lot of tables together, particularly if the database is fully normalized. So when we're tying that data together, maybe we're searching for some specific data, and that's why it's beneficial on a primary key. And then in terms of the integer column, that's obviously smallest in terms of storage as well. I'm just going to explain a bit more what I mean about a B-tree. So if we go back to our filing cabinet scenario, if we imagine we had three larger files that stuck out, and say the first one told us that this is where the data for A to F is stored, we would know if we're looking for the surname Barnes, we go there, and then it would be broken down further, so it's a lot faster to get to where we need to go. And I've put that as an example on this screen. So if we're looking to retrieve data row 1, for example, we start off and we've got 1 to 10. We go down that route. We can throw away the 11 to 30 straight away. We know we're not going to be finding what we need in there. And then we go to the 1 to 5 route, and then eventually we'd get to our data. The same if we were searching for 30. So that's an example of how a B-tree would work. And I've also came up with a simple game, the Btree game. So I'm thinking of a number between 1 and 100. You can only ask me yes or no questions. Now if you was to sit there and say to me, is it 1? No. Is it 2? No. Is it 3? No. You can imagine that would take a very long amount of time. And in terms of SQL, that would be what was known as a table scan. So we're going to have to scan all of the data to find out what information we need to actually return. Or the alternative is if we can divide that data by 2 straight away. So is the number greater than 50? No. Brilliant. So we know the number is from 1 to 49. Is it greater than 25? Yes. Okay, so now we know it's 26 to 49. Is it greater than 37? No, and so on. So we get to the answer a lot more quicker through using a Btree and how we're storing data. Quite a long introduction there, but hopefully you have got an understanding of what we're going to be doing. Now we're going to go over to SQL Server Management Studio and we're going to have a look at how to create clustered indexes on some tables. So I'm in SQL now and I've wrote out a simple create statement for a new table, employees. So we can see, just going through the create statement, I've got EmployeeId, which is an integer column, an identity column for this table. So I'm going to go ahead and create this table now. I'm just going to execute that. And then I've got just some dummy data here that I'm going to throw into that table. So if I go ahead and execute that now, that table has now been created. By the way, if you do see a bright circle on the screen, that's just where the mouse is at the moment. I've had some feedback from some subscribers just asking to show where the mouse is, and it's particularly important for what we're going to do next. So typically we'd be using a lot more data, particularly in a real life scenario, but I've just got 5 rows in here. Now what I'm going to do is turn on the execution plan. So there's a couple of ways we can do that. We have this icon here in SQL Server Management Studio, which will enable us to show the execution plan. So we can select that and it will show. Or we could go to the query window and include actual execution plan here. Or there is a keyboard shortcut of pressing Control M. So we're going to see that shortly, but what that will show is how the database engine has actually processed our query. I will post the sequel from this video in the comments below, so if you've got to this stage, make sure you have got the actual execution plan turned on. Now what we're going to do is just run a simple select from the table. So at the moment I'm going to just select all of the data. So I'm just going to run a select all. And then we have the option here of selecting our execution plan. And as we can see, within the execution plan, we've got a table scan. So we now know that this table is stored as a heap. There's no clustered index on this table, and it's performing a table scan. It's retrieving all of the data, or rather it's going through all of the data. So I'm just going to close that now, and I'm going to search for an employee ID of 3. So if I go ahead and execute this now, you can see we have got 1 row returned, the correct row. And if I look at the execution plan, we're still performing a table scan. What ideally we want to be in the position of doing is performing a index seek. So as I mentioned, when searching through the filing cabinet, we go to the A to F section first. We know the data is within there, and then we go down our Btree levels until we actually retrieve our data. So we're going to have a look at now how we can create clustered indexes on this table. I also need to point out here that if you are creating a clustered index on an existing table, it may take some time. That index has to actually build. So if you have a large amount of data within the table, that's actually going to take some time. I only have 5 rows here, so it's not going to take much time at all. So the first demo we're going to through is using Object Explorer. So I'm going to open up my table here. I can see my columns. I haven't got any keys on this table, and if I also open up indexes, I haven't got any indexes on that table either. But what I can simply do is right click here and click on new index, and then it gives me the options for the indexes I can create. So you can create a clustered index, non-clustered index, or a non-clustered column store index. In this video we're going to be looking at clustered indexes, but we will be doing videos further down the line on non-clustered indexes and column store indexes as well. So we're going to create a clustered index. So if I just click there, it's came up with the table name for me, the index name, so that's going to just be defaulted to whatever SQL has said, our index type. And we can see here we need to add at least one column to the index, so we can add indexes on multiple columns. So I'm going to click on add, and we're going to be using the ID column. So as mentioned, our ID column is an integer column. It's an identity column, so it's ever increasing, so it's ideal for us to create a clustered index on. So I'm simply going to select that and click on OK. And we also have the option of selecting whether this should be unique or not. So if we go ahead and click on OK, that index is going to be created for us, and as we can see in Object Explorer, that has appeared. So as I've mentioned, that was relatively quick, but if you have a large table it may take some time. So very simple way there to create a clustered index. That index has gone off and been built, and that table will now be stored in the order of EmployeeId. Now if we want to have a look if a table has an index, we can query a few system tables. So we're going to be having a look at the systems partition table. So I've already wrote out this query. So initially I'm going to the sys tables just to get the just to make sure I'm working with the correct table, and then I'm going to join that to partitions table just to check that this has an index. So I'm going to go ahead and execute that, and we can see the index ID of 1. So this table has an index. I can also see what type of index by looking at the indexes built-in system table. I'm not going to query that now, but we will look at that. As you can see, that's not the correct name for our index, but we're going to go ahead and look at another way we can actually create an index. Now we're just going to go back to our initial query. So again, we're going to run our select all. Actual execution plan is still on, so if we go ahead and execute this now, and we've got all the data retrieved, and we look at our actual execution plan, we've now got a clustered index scan. So we've got a clustered index on the table. It's still going through all of the data, which we would expect, because it's actually retrieving all the data. We're asking the database engine to give us everything back. But now what I'm going to do is change this to run where EmployeeId is 3. So if we select all from there, again we've got the correct data, but if we look at the execution plan, we've now got a clustered index seek. So that is a lot faster than performing a full table scan. Think back to my example of a filing cabinet earlier. You might be thinking at this point it's very rare I would run a query looking for a particular employee ID. Typically I'd look at name or when they started with the company, but that is actually going to be a joining column. So if we have a sales table, we're going to have a foreign key in there to the employee ID, so quite often we're going to join that data together to retrieve information from this table, which is why it's always considered best practice to have it on the ever increasing integer, particularly if you're going to be using it as a join column or a primary key. We're now going to drop this table. So I've got this statement here just to say if this object exists, drop the table. And in doing so, in dropping that table, we're also dropping that index as well, because that index belongs to that table. And now we're going to go through another example of how we can actually create this within our create table statement. So simply what I'm going to add here is just a constraint statement, You can see I've got one on screen for the employee start date as well. That's just a default constraint. So I'm going to be calling this PK. I always like to, with my constraints, I always like to prefix them with what type of constraint they are. So in this case it's a primary key. In the other example that's a default constraint, so that's why that's prefixed with DF. And then I like to name the table and then underscore the column name. So in this case EmployeeId. It's going to be a primary key constraint and the column is going to be on EmployeeId. So now we're going to go ahead and create this table. So that's executed successfully. So if now I go back to Object Explorer and just refresh this table definition, I can see my employee ID there as a primary key. We've got that under keys, and we've also got our index created with the name of the constraint. So if you're creating a table with a primary key constraint, as we know, we don't always have to give that a name. There will be a default name created for us, but it tends to be sort of a hexadecimal number that that SQL creates, so I always prefer to name them myself. And the name of the constraint will also be the name of the index. So if we go ahead and, as mentioned previously, I look at what type of index I've got against my table by querying the sysindexes table. So I'm looking for this index name. We can see the name here, the type. So type 1 is clustered, type 2 is non-clustered, and type 0 refers to heap, but we also have a type description, so we can see we have created a clustered index against this table. So that's another way we can create a clustered index, simply by adding a primary key constraint. We're going through one last example now, which is how we can, an alternative way to add a clustered index to an existing table. So rather than using Object Explorer, I don't tend to do that, to be honest. I like to script everything out. So we're going to drop the constraint that we've just created, drop this table and recreate it. So we're going to go ahead and execute that. So that will drop the table and recreate it. And then we can run an alter table statement. So again, because the table, if we insert the data, the table will have data in there, so it has to actually execute, it has to actually build the index. By the way, the reason I'm just getting that instead of the 5 rows inserted is because of I've got the execution plan active. So we can simply do that by running an alter table statement, as we would to add a constraint to an existing table. So first of all, I'll refresh in Object Explorer to say we do not have an index at the moment, but rather than right clicking here and creating new index, I always prefer to script out everything I'm doing. So I can go ahead and execute this now, and that's going to build the index for me. So again, if I just refresh the table definition, we can see that that index has been created. We can open up the properties on that to see, again, this is the similar page to what we looked at previously, but it's worth noting as well, because we have done it as part of a primary key constraint, it has created a unique clustered index for us. So I really hope you have enjoyed going through those examples. As mentioned, I will put the SQL script into the comments, so if you want to follow along with the video, please feel free to do so. Any questions, do put them in the comments for me as well, and I'll come back to you as soon as possible. I'm just going to go through some further points regarding clustered indexes. So it doesn't have to be on a primary key. We could have created a unique clustered index, so we don't have to have a primary key in the table. We can just create a clustered index. The column doesn't have to actually be unique. So if we was creating a clustered index on a date column, for example, it's very unlikely that that would be unique, but the database engine SQL will create a unique identifier for us, and that will add storage costs, so our storage will increase ever so slightly. We can also create clustered indexes on multiple columns and other data types, so as I mentioned there, date or string data types as well. It can be used in conjunction with non-clustered index that we'll move on to in other videos. And remember that indexes do need to be maintained. They can become fragmented over time, but the indexes can be rebuilt or reorganized. So typically that's during maintenance periods that we would have a job that would do that for us. And we'd also measure sort of the fragmentation. So if an index is fragmented by 1%, it's probably not worth reorganizing it. But typically, everywhere I've worked, we have it on a schedule that would check the fragmentation, or maybe we'll just do it weekly during low periods of database usage. Do check out my other videos on the channel. If you haven't already, please do subscribe and click that notification button to be made aware of when new videos are uploaded. Thanks a lot for watching.